Okay, so in fourth period, I went over problems 1 and 2 with the class, and then I ran out of time to go over the third problem. The third problem is basically review of trig functions. So in this case, we're given a sine function, and we need to figure out how it's been transformed. So if we remember back to what sine usually looks like, it usually starts at 0, 0, and it goes up, and it goes down, and it comes back up again. So that's what it normally looks like. So you can tell a couple things happened. One is it got shifted up. The vertical shift is this letter right here. In our notes, we called that D, but they're calling it C. And another thing that happened is the amplitude. That's this guy right here. Normally it goes up to 1. But you can see that this is quite a bit more than 1. My amplitude, usually this distance right here, from here to here, is 1 unit. And this clearly, if I draw my principal axis here, you can see that this is clearly more than 1. Okay, so, and then the B, that has to do with the period, okay? And also notice instead of going up to start with, it's going down to start with. So that means my A is negative. So I have a negative A. All right, so just to get ourselves situated there. Okay, so to make it go down, we know that our A is negative. We also know that our A is more than 1. Normally it's just 1, our amplitude. This has greater than 1 amplitude. And my principal axis has been shifted up, and this is the principal axis right here. Okay, and then this is for the period. B is for the period. Normally the period is 2 pi, and remember this is in backward land, so it's not B times 2 pi, it's 2 pi over B. So period is equal to 2 pi over B. So that's some of the background information that we need. Okay, and A is amplitude. So if you don't remember that, that's the reason why we have notes. Look it up in your notes. Okay, so let's see what it says here. The graph of f has a minimum point at 3, 5. Okay, so right here, that's at 3, 5. And a maximum point at 9, 17. So right here, I'm at 9, 17. Find the value of C. Okay, so C is where our principal axis is. Where's our principal axis? It is at 11. So C is equal to 11. It's been shifted up 11. Okay, show that B is equal to pi over 6. Okay, so as I was mentioning, the period is equal to 2 pi over B. I'm trying to solve for B because it says show that, so that means I'm trying to solve for B. I cannot use this to get started. So instead that must mean that somehow I know what the period is. So the period is how long does it take it to get from its starting place back to its starting place. Okay, and so we have that by looking at this. It takes 12. So the period is 12 units. Because from here back to where it started, that's lining up at 12. So I know the period is 12. So 12 is equal to 2 pi over B. So to solve for B, I'm going to multiply both sides by B. So I get 12B is equal to 2 pi. And then I can divide both sides by 12. And I get B is equal to 2 pi over 12. And I can reduce that, divide both of those by 2, and I get pi over 6, which is what I was trying to show. So here is the showing part. Show that B is equal to pi over 6. So notice I did not plug in pi over 6 at any point, because I'm trying to find it. All right, find the value of A. Okay, so A is just what's my amplitude. To get my amplitude, I could just look at it and count. It looks like it's 6, but to do it more mathy, it's the halfway point between the y values, between 5 and 17. So how do I get halfway between 5 and 17? I add them together and divide by 2. So 5 plus 17 divided by 2, so that gets me, I'm sorry, I subtract them. What am I doing? If I want to get halfway in between them, I'm going to subtract them, because the average is the axis of symmetry, sorry. So I'm going to subtract them to get how far is it. Or actually, there's a couple ways I can do this, now that I think about it. I know the principal axis is 11, So how far is it to get down here to 5? So I could just do the principal axis minus the y-coordinate of my minimum there, and that gets me 6. I could do the same thing here. I'm up at 17, and how far is it? Down to 11. So I could do 17 minus 11. I also get 6. Okay, the way that we have it in our notes is we have 17 minus 5 divided by 2. So 12 divided by 2 gives me 6. So A is equal to 6. That's our amplitude. But since it's upside down, I have to make it negative. Okay, so this distance is 6 units. Okay, 6 units. But I'm going down instead of up first, so it's A is going to be negative 6. So A equals negative 6. Boy, I sure made a mess out of that. Okay, use your graphing calculator to check your answers. So the idea now is to put this into our graphing calculator. So where is my graphing calculator? Okay, so into my graphing calculator, I'm going to plug in what I think my equation is. So it says the graph of G is obtained from the graph of F by this translation. The maximum point on the graph of G has these coordinates. Okay, so here was my original maximum. I'm going to be transforming this. This is the x direction. This is the y direction. So notice I'm just moving in the x direction, and my maximum is going to end up at 11.5 and 17. So notice the height is not changing. They both have a height of 17, but it is moving over to 11.5. This is going to be my new maximum, 11.5 and 17. So how far over did I shift? I shifted the difference between 9 and 11.5. So how far did I shift? That's my K value. So what's the difference between 11.5 and 9? That's equal to 2.5. So K is equal to 2.5 because that's how far I moved to get from this maximum point to this maximum point. So I wrote down the value of K. Now actually find the function. Well, in order to find G of x, it helps if I have f of x. So f of x is equal to, we said A was negative 6, and then its sine, and we said B was pi over 6, and then x plus c. C was my principal axis, which was 11. So there's f of x. So one thing I can do is I could actually put that in here into my calculator and check and make sure it makes sense. Negative 6 sine of pi divided by 2 x, close parentheses, very important to close those parentheses, plus 11. Let's graph that, see how it looks. Okay, that's looking pretty good. Notice I probably want to change my window because my y value, I don't need to go down to negative 10. I'll just go to negative 1 so I can actually see my y-axis, my x-axis. And I need to go up to, let's change it to 20. Okay, that's looking better. I probably could have changed my x as well. So let me go ahead and do that once it lets me. So I'm going to go from negative 1 up to positive 12. I'll go a little farther than that. How about 13? So I'm changing my window. And now you can see it does look more like the, oh, wait a minute. Okay, I have way too many things happening in here. So what did I do? So we said B was pi over 6. Pi over 6. Did I, somehow I messed up. Oh, I put a 2, that's why. All right. Let's see if that helps. Now it looks right. Okay, so if it doesn't look right, check your work. Because mine didn't look right, so I needed to check my work. Okay, so that looks a lot better. That looks like the original graph. Now I want to make it shift 2.5 to the right. So remember, horizontal shifts happen in here. So my G of x, I'm going to still have my A. I'm still going to be sine. My period's not changing. What is going to change, and I need to put in a second set of parentheses here, is I'm going to be moving 2.5 to the right. Remember, this is backward land, so I'm going to need negative 2.5. and then double parentheses plus 11. Okay, and then we can graph that, negative 6 sine pi divided by 6 x, oops, double parentheses, sorry, second set of parentheses, x minus 2.5, close, plus 11. Okay, so I typed in my g of x, and I'm going to graph that, and we should see it's just shifted over to the right. So when you're doing this, if it doesn't look like mine, double check how you did your parentheses, because you need to have double parentheses around the shifting right and left, and then have the multiplication outside of that. Okay, so here is my equation. That's looking good. It's shifted 2.5 to the right. Okay, the graph of g changes from concave up to concave down when x equals w. So from concave up, so here's my concave up right here, to concave down, it's going to be halfway between my maximum and my minimum. So halfway between my max and my min is where it's shifting. I also could take the second derivative. I could take derivatives, but it's a lot easier to just realize that this is a very symmetric function, and it's going to be shifting from concave up to concave down, halfway in between these 2 points, my maximum and my minimum. Okay, so in order to find w, what I need to do is I need to find halfway in between. Let's see, am I doing it on G or F? Okay, I'm doing it on G. So I need to find halfway in between this max and the minimum that was over here. So remember, I just shoved this over 2.5. So my minimum, I'm going to add 2.5 to my 3, so that gives me 5.5. The y value stays the same. That's going to be my minimum. Here's my maximum. So it's going to be shifting halfway in between 5.5 and 11.5. So what's halfway in between that? I'm just going to add them together and divide by 2. So 5.5 plus 11.5 divided by 2. So that gets me, let's see, 12 plus 5 is 17. Divided by 2 gives me 8.5. Okay, and that looks about right. So it's shifting at 8.5. Oops, can you see my work? Sorry about that. 5.5, the x-coordinates of the minimum and the maximum, added them together, divided by 2 to get halfway in between them. So w is equal to 8.5, which is the x value where I'm going to have my change from concave up to concave down. Okay, hence or otherwise, find the maximum positive rate of change of g. Okay, so the fastest rate of change, the maximum positive rate of change, is going to happen at this point. So if you look at the graph, that's where my slope is the steepest. Right before it switches directions is where it's at its steepest. So I want to find the rate of change. So I already have my g of x in here. So I'm going to go ahead and I'm going to take out my f of x. That's that one. So I only have my g of x. And I want to find out what is the rate of change at 8.5. Well, rate of change is dy dx. So I can use my calculator. I have my function in there, so I'm going to do the calculate menu. I'm going to go to option 6, which is the dy dx. And I'm going to ask it what happens at 8.5. And it tells me my rate of change is 3.1415925. Does that number look familiar? Holy moly, 3.1415. Oh my gosh, isn't that crazy? It gives us pi. Why is that happening? Oh, time's up. Good thing I just finished. All right, hope that helps.